So let's look at what's called a standard score or a z-score. We had what's called, normal distribution on a bell-shaped curve that kind of described how the data was distributed with respect to the mean. And we had this thing called standard deviation, which described how the data varied with respect to the mean. So z-score is going to be, again, something to that effect. It's going to represent the number of standard deviations a value x lies from the mean, and they're going to be using mu here. So to find the z-score for each value, we're going to be using the formula that z is going to equal the value given, take away the mean, and we're going to divide that by the standard deviation. And recall those symbols, x is going to represent the value given, mu is going to represent the mean, and sigma represents the standard deviation. Again, these are if we're talking about a population. So the distribution of ages of the winners of the Tour de France from 1903 to 2016 is approximately bell-shaped. The mean age is 27.9 years, with the standard deviation of 3.3 years. Use the corresponding z-score to determine whether the age is unusual or not. So if we do that, the mean would be like 27.9. If we go one standard deviation to the right, let me find me a calculator. We'll pause for a second. Didn't have a calculator handy. So since it said 3.3 is my standard deviation, so if I go one standard deviation from the mean, if I add 3.3 to that, that would give me an age of 31.2. If I add 3.3 to that, that would give me like 34.5. And if I add 3.3 to that, that would give me like 37.8. Now, if I go the other direction, if I have 27.9, take away 3.3. If I go one standard deviation, that would be like 24.6. If I go subtract 3.3 again, it's going to give me 21.3. Then if I subtract 3.3 again, that'll give me like 18. So notice that, most of the people who won the Tour de France are mainly between the ages around 25 to 31. And then it's not as common for somebody younger than 25 to win. And if you're over 35, it's starting to become kind of unusual. So if you're like between 95% of the data here, it's kind of not bad. But if you're out here closer to the ends, so if you're around 18 or 19, or if you're around 37 or 38, getting closer to that, then that's going to be kind of unusual. So you can kind of see that as they put the data together. So we're asking, is Christopher Froome, 2016, we have his age is 31. We want to determine his z-score. So determine his z-score, his standard deviation, if you will. So let's see what's it. It represents the number of standard deviations. So the number of standard deviations is what that's going to be. So let's see if we can put that together. So z-score is going to be represents the number of standard deviations. And we said it's going to be x minus mu divided by sigma. So the data is this 31, and we're going to subtract the mean, which is 27.9. And if we divide that by 3.3, let's see what we can come up with. So let me slide this over to the right, and we'll get the other big boy calculator out here. We'll minimize this here. Got all kinds of stuff open. All right, let's see if we get this open here. Okay, let's see if that'll get open. We'll slide him over here to the left here. Oops. We don't want the whole thing. So I was in a plot. So again, I'm gonna hit the second button and hit mode. It'll get me out of there. So again, I can create this as a fraction. So if I hit the alpha button and hit the y equals 1 or the y equals button, it'll actually do this F1, which creates a menu for us. Notice the number 1 is N over D. So if I choose that, I can now just type the whole thing in if I want. So this 31 take away 27.9 and put that under 3.3. And that gives us a z-score of 0.993, or so that'd be about, so it's going to be about approximately 0.94. Or sometimes, we can actually go out to, I just do 0.94. They'll ask you to round it. So notice that that's not even one standard deviation. So if it's not even one standard deviation, then, from the mean, I'm going to be between the age 31.2 and 27.9, probably really, really close to 31 would be my age. So that's not really unusual. So since the standard deviation is less than 1, that's not unusual as far as things go. So that's not an unusual age. Age 24, if we look at the bell-shaped curve, 24, we're starting to get past this a little bit, but not by much. So just by looking at the bell-shaped curve, age 24 does not look that unusual here. So if we go ahead and figure out the z-score, so for this one, so I'll give myself a little bit of room. So z equals, again, the x is the data, 24, minus the mean, which was 27.9. And if we divide that by the standard deviation, which is 3.3, that'll tell me how many standard deviations this is from the mean. So again, I'm going to use the alpha button, alpha F1, use the N over D button. And I'm just going to type the whole thing in. So 24 take away 27.9 and divide that by 3.3. Notice that we get a negative 1.18. So that means to move left of 27.9. So negative 1.18 would put us about right here, just to the other side of 24. So remember, 95% of the data is still between 21.3 and 34.5. So again, I would find age 24 not unusual. That seems to be something that we see happen. Age 27, again, age 27, that's right smack in the middle. I can already kind of see that that's not unusual, because that's really, really close to the mean. So that would be my explanation is, 27 is really, really close to the mean. Again, I could find the z-score as well and just see what that is. So I have z equals then, and also 27 is left of 27.9, so it should be a negative number. So 27 take away 27.9. If I divide by 3.3, let's just actually see what that z-score is. So again, I'm going to use the alpha F1 button. So alpha, hit the y equals button, it'll do the F1, hit the 1, and then I have 27 take away 27.9. And then if we move down to 3.3, hit enter. So that's we get negative 0.27 as our standard deviation. So negative 0.27, again, it's just going to make us move a little bit to the left of the 27.9. So again, we would say that that's not unusual because of that z-score being so small. It's not even one standard deviation. And still, one standard deviation is good. It's when you get out there past 2 that it's not so good. So if I look at age 36, notice that age 36 is, let's see here. So if I look at age 36, notice it is out here close to 37. So I'm already kind of feeling that's going to be kind of unusual. Let's see what kind of z-score we get here in doing that. So in calculating z-scores for this one, again, this is how many standard deviations from the mean to go. So again, this is going to be 36 subtract 27.9. If I divide by 3.3, that'll tell me how many standard deviations to move from the mean of 27.9. So again, I'm just going to clear all this out and hit alpha F1, number 1. Again, it's going to be 36, take away 27.9, down arrow it, divide by 3.3, hit enter, and that gives me 2.45. So notice that 2.45, this is one standard deviation, this is two standard deviations, 2.45, that's about out in here somewhere. So notice that that's kind of out there where it's not as common. You really need to be between two standard deviations to be kind of common. So we would consider age 36 kind of unusual. So we would say that's unusual because we're out there past two standard deviations. So notice that, still kind of high out here. Really between 24 and 31 is really, really common. And it's not that uncommon to be between 34.5 and 21.3, but notice how the curve gets even closer and closer. So that makes it indicate that we're getting into the unusual area of things. So hopefully you can see that as a useful way to do RC scores.